Okay, so I guess we'll get going. So I thought I'd kind of go back over a little bit some of the graphing stuff that we already did, repetition for reinforcement, and try to explain it a little bit better. So you can feel free to follow along if you'd like. Do you guys want to turn out the lights there? Would it be better to see? Leave the door open for that light. Yeah, awesome. Okay, so.
No, she can't eat it. Okay. Sorry.
So I have a new session of ours, so I'm going to load up the ggplot database. With that, it comes with the MPG.
Do you have to load it every time?
You have to type library ggplot every time, yeah. So good practice is when you sort of start your new script, put any library that you think you're going to use at the top of the script. If you're writing and you realize, oh, I'm going to use this package, good idea to put that again at the top of the script. Give somebody that's coming along looking at your code a good idea as to what packages they should install so that they're available.
Can't you just change the defaults of RStudio to have select packages that are loaded?
Yeah, I like to do things by code as much as possible. So don't rely on settings having been set in at some other time.
Tibbles?
Let's do it. Yeah, Tibbles. Oh, Tibble, I guess. Did I not? Oh, I haven't installed it on this machine. So I will go install that packages.
That's a great idea. I will join.
All right, so now I should be able to load in the Tibble library. So I think we were dealing with the MPG data set before. So it's a table with, or a table with 234 entries for 11 columns. We talked about how this is sort of fuel efficiency database for lots of cars for a few years. And I think we did a dot plot of like engine displacement against highway mileage. So let's do that. We're gonna create a base ggplot object that we'll paint on. So I'll say base equals, or I guess maybe canvas ggplot, and I always want to type 2 there, but it's just plain old ggplot. And say points layer equals point. So point, it wants to know where should it look for data, and that's the MPG data set. Point wants to know what aesthetic attributes are going to be mapped to what aspects of the data. So mapping is the name of the argument, and mapping wants as its value a call to the function AES. So got sort of a nested function call to AES within the call to point. So AES really is just a list. So x equals, and we tell it what column in this we want to put on the x-axis. Let's put displacement, DISPL. And on the y-axis, let's put highway mileage for this. And that, if I say my plot equals canvas plus points layer, that will create a plot. Okay, so let's actually step through each line of this code. I've got creating a blank canvas. So if I actually try to print canvas, nothing happens. A big blank thing comes up. I started the recording, right? Oh, did I? Yes, I did. Yes, I did. Okay. Then I create a points layer. But again, nothing actually happens. This plot hasn't updated. If I say print canvas, nothing's changed about this canvas because I haven't. The points layer simply is sort of like a set of instructions. If we say print points layer. It's got kind of, it repeats what we kind of told it over here. This isn't in code form. It's told us the details of what we've given it in code form over here. So in order to create an actual plot to tell to combine these two things, we just use the plus sign. It's a little weird to have two kind of non-mathematical things being combined with a mathematical formula, but that's just sort of the shorthand for doing that. So having created this plot object, we can look at it. So canvas again, print canvas, hasn't changed, that's just a blank thing. But if I say print my plot, having run those, there's the plot. Yep.
If you don't assign canvas and points layer to an object, can you just ask it to print the combination of both layers?
Yep. So if you don't want to do this creation of objects, I'll copy that little bit of code, but I'll paste it down here so we don't lose what we had above. And I'll just say ggplot and plus geonPoint.
Oh, okay, right.
I can do that, and that will run as well. In fact, this is the more normal way of doing things, not creating objects and then specifically layering them. I'm teaching you creating the objects separately. I've found people learn the ideas a little bit better because there's other things we're going to combine together. It's also a little bit easier to find when you've made an error. So say I did that. No, that's not gonna. Say I wrote the argument down incorrectly there. The error is gonna pop up right as I try to define that function, so it helps me narrow down where I made my error a little bit easier than if I had lots of layers being added together all in one go. The error is going to come up at the end, and I don't know where in that sequence of additions the error was. So we also talked about how you can, so these X and a scatter plot, a plot of points, the required aesthetics are X and Y. We told X to be a function of this column in the data and Y to be a function of this other column in the data. We could have told each of them, so if I take off Y and I just say Y equals 0. In this scenario, X is a function of the data, but all the points are going to be drawn at Y equals 0. So anything inside the call to AES are things where it's aesthetic attributes that are varying from as a function of the data. Anything outside are aesthetic attributes that are a constant for the data. So if I run this, they'll all be plotted along the bottom. Not super helpful. They'll actually show you a scenario where it could be in a little bit. There are other aesthetic attributes. So you need an X and Y no matter what. If I take off, say, this Y here and run this, it's going to give us an error. Error requires the following missing aesthetic. And indeed, if we search geonPoint and scroll down to the details section and aesthetics, geonPoint understands the following aesthetics. Required aesthetics are in bold. So X and Y are in bold here, and that implies that they're required. So, I need the Y. If I want to change, say, the shape, that's another one that you could change. So shape, there's numbering associated with those shapes. There's a table in the R for data science for what numbers correspond to what shapes. Let's add a, sorry, go ahead.
You put it outside of the inner parentheses.
Yes, well, anything that you want to be the same for all the points. So they're all shape equals, I think I had 8 in this example. One that's useful, particularly when you have data that looks like this, where it seems like they've got regular values, is alpha. That makes each point potentially semi-transparent. 1 would make it completely opaque. 0 would make it completely transparent. 0.5, though, makes it halfway between transparent and opaque. So if I run that, we'll be able to see the places where there's more data. It's going to be darker dots. So that's useful. Something I didn't show you the other day, but is also useful in this context where you've got overplotting, is that you can set the position. So every geometric object has a position argument. So the default value for position is identity. That means that when it's drawing the object, it's just going to draw it where the data says to draw it, or where you might have told it as a constant there. An alternative value that position can take is jitter. And what that's going to do, it's going to add just a little bit of random noise to where it shows each point. You could do this by actually changing what's in that data frame, adding some random noise to the columns in that data frame, but it's actually, you'd have to choose like how much noise, etc. ggplot has figured out that this is a common thing and has figured out how to do this nicely all by itself. So by putting position equals jitter, those points will move a little bit off of where they're supposed to be in order to see sort of the general density of where all the data points lie. So it's a nice little trick. Yeah.
Can you alter how much jitter? Or is that a set?
I've never looked at that. Let's see. There's a geom jitter. Actually, I'll do it up here. Geom, which is the same as stat jitter. And does it have any arguments that seem useful?
Maybe.
So geom jitter is actually the same as what we have here. It's a sort of shorthand for geom point position equals jitter. There's often a bunch of those. I don't see any. Oh, width.
Yeah, I was going to say
Width and height, yeah.
So yeah, you can explicitly tell it to jitter specifically. So if I said width, I wonder.
you have to put it in a geom command.
I wonder. Let me see. I'm curious. Because it might be smart enough to pass unknown parameters width. If I say maybe no, it's not going to be that smart. I probably would have, if I want to manipulate specifically that, I probably have to use geom jitter.
Maybe that's why they've done it that way. That's too bad though, because then you can't really manipulate like a few different things. If you want to mess with jitter and then something else maybe.
Well, I mean, in theory, if you did geom jitter, you can still change everything else. You just would additionally have the ability to manipulate the amount of jitter.
Right.
Additionally, if you only want to jitter certain things, you can break your data frame into two objects and then load part of it into points and part of it into jitter if you only wanted some of the points jittered.
So would this just be something like as you're exploring your data that you would
Yeah.
use? Because you would never publish something like this, would you?
Jitter? Yeah, probably not. No. Alpha? Yeah, I think that's a good idea. But not jitter, I'd say.
Just out of curiosity, is jitter actually altering the values in the database, or is it creating kind of this unseen object where it's
the latter? So unless you actually see something of the form of MPG equals or MPG dollar dispo equals, if you see that, that means that the MPG object is being changed. Anything else is going to create an object of the MPG data frame and do any manipulations it needs to that copy. It's completely, anything that happens inside a function stays inside a function thing.
Well, yeah. No, but not with that object assignment, that is true.
What was the dollar sign for? Like if you put the
Aha.
database in the dollar sign?
Well, I haven't told you about that, mostly because we're not going to need it. But if you need to, like, specifically alter the data, we've got this MPG data frame.
Right.
If I want to talk about the dispo column within the MPG data frame, I can talk about it like this. So if I just said print that, what it's going to do, it's going to see the $, and it's going to say, okay, look for a data frame named this, the thing on the left, and within that data frame, look for a column named the thing on the right. So if I ask it to print that, it's going to print me the entire contents of that column. When we get into manipulating data frames and things, we're going to be using a different way of doing things, so you won't need to know that necessarily. But you'll see a lot of code out there that use this. I guess this is the more traditional way of referring to columns within data frames, and a lot of code is out there already that does it that way. But we won't need it, I don't think. So, yep, we also talked about the idea that you can create like labs layer. You can, if you don't like the names that are there, you can, for anything that's sort of data dependent in your plot, you can change the label associated with that property of the plot. So there's an X property of the plot, there's a Y property of the plot. If we had different colors, that would create a little legend, and that legend would have a title. So X, we'll call that engine displacement, and Y equals highway MPG. I'm going to, instead of putting labs layer at the end as plus labs layer, I'm going to actually start breaking this onto separate lines so that my code isn't going way off outside the window here. When you break, so I showed you before, whenever I have a function and then lots of arguments, I like to put each argument on its own line, starting the line with commas. This is a scenario where you actually have to put the thing that separates stuff at the end of the line. So we've got a sort of computation happening. Canvas plus points layer, and we'll say plus labs layer. Ideally, like if you think of this, plus is kind of like a comma, therefore maybe ideally you put the pluses at the beginnings of the lines. You can't do that. R doesn't like it. You have to put the pluses at the end. But having done so, and I need to run this little bit so that labs layer actually gets created, and then I run this bit to combine them all together, and now I've got nice little labels. I'm going to look at this MPG again quickly to see what's in there. Class is one kind of car. CYL. So if I wanted sort of, again, to use color to differentiate the different car classes, I could add this to the mapping argument, the points layer, and then run it all. And that will update the plot to have this other thing. And again, if I want to change the label associated with the color, the thing that the color argument creates, which is this legend here, that's it, color equals, and here we run that. Now it's capital C class. So this is mostly review from yesterday, or the last class. I think we also talked about creating faceting. So if we wanted to, let's see, have the...
Sorry, just quick questions.
Yeah.
But before you go on, does it not matter whether color is spelled with a U or not?
It does not. It's
okay.
Smart enough, yes. You noticed here, it's color OR, here it's OUR. It's smart enough to know.
And it doesn't matter that it's single quotes and double quotes?
Single quotes and double quotes, nope, doesn't matter either. I tend to prefer single quotes, but yeah, sometimes I prefer single quotes because you don't need to hit shift, you just do it. But yeah. So no, single quotes, double quotes, doesn't matter. We talked about faceting. So if I had yet another variable, and instead of sort of making a single plot and using all the aesthetic attributes of the points to differentiate sort of categories of the data, maybe I want to put the manufacturers in different plots, but have those two plots on the same page. That's what facets are. So facet layer. So there's two faceting things. There's facet wrap and facet grid. Use facet wrap. The first argument to facet wrap is called facets. And this expects either a formula or a character string or a vector of character strings. I showed you formula last time, and that was a mistake because after playing with it, it actually is way easier to use the character string way. So if I just wanted manufacturer, I can just put the string manufacturer, and it will look for whatever data is in the is being plotted. It will look for a column with that name. I can't actually put I can't put the word manufacturer without quotes. It needs quotes because facet wrap it doesn't have a data argument like GLPoint does, so it doesn't really know where to find things. So I have to put quotes around it, and it's only at the ends then when things get added together that it's going to look for a column within whatever data is available in the plot for a column with that name.
Sorry. So did you say facet wrap is like the function, and then as an argument you said it needs a character string?
Yeah. So the argument name is facets. The value we're passing to that argument is just the string, the character string manufacturer. So let's run that from the top. So it's going to print. So here's all the manufacturers. There's a lot. So what's nice is that it's automatically sort of made like a little grid. Because there's 1, 2, 3, 4, 12, 15 different manufacturers of this data set. So it's automatically sort of wrapped them around so we can kind of see the different manufacturers. You can sort of see that Subaru has somewhat high MPG, well, middling range MPG, low engine displacements. Other manufacturers maybe have larger displacements, lower MPG. Honda has really low displacements, really high MPG. So you can see a little differentiation that way. I mean, we will deal with a couple cases where we use faceting. I'm not a huge fan of faceting. You can actually have multiple variables contributing to this faceting. So let me actually look at MPG again.
Model.
Sorry?
Could you not break up by model as well in facet?
Yeah. I'm going to look for a couple that are fewer sort of levels.
I have an error that says at least one layer must contain all variables used for faceting. But the code looks...
So there's... Oh, did you maybe capitalize that? Look for the string you passed there. Is that misplaced?
Manufacturers.
Gotcha. Yeah, it's a skill of patience that one learns in any programming language, because often the error messages aren't super helpful, particularly in R, but often the error that's being made is something stupid, like I forgot to pluralize or I did pluralize when I shouldn't have. So, yeah.
I get a different error. It says, don't know how to add facet wrap to a plot.
You want to add facet layer.
Right. So you had it such that you were adding the word facet wrap, which actually does refer to the function, but you weren't using it as a function, and R doesn't really know what to do with that. So, yeah. If you wanted multiple things, let's say I wanted to do transmission and drive. So I'll do trans first. And I only need to select like as far as that change of the layer. I have been selecting everything, but I happen to know that I'm only changing this much, and then I'm adding them together again, so I don't need to select everything. Print. Okay, so there's the transmissions. That's a lot of transmissions too.
Year. Again,
Year, yay, that's a good one. Year. Something with low. So there's only 2 years, so it's decided, I mean, it can either choose to put them in rows or columns. It chose rows. Okay, so there's year and sil. Let's do sil. So if we wanted 2 things, so year, come on. Can run that. Okay, so there's 4, 6, 8. Oh, interesting. So there's actually 4 levels of cylinder, but because so for 1999, there's some 4-cylinder data. For 1999, there's some 6-cylinder data. For 1999, there's some 8-cylinder data. For 2008, there's some 4-cylinder data. For 2008, there's also some 5-cylinder data. In 2008, there's 6-cylinder data. In 2008, there's 8-cylinder data. So 99 didn't have any 5-cylinder data. That actually almost looks like it's probably a typo in the original data set.
Yeah, there are only 4.
Yeah.
And they're all like back in the same rows.
Yeah, so maybe that's a typo in the original data set.
Sorry, why did you put the C? What does the C do?
This is the function we use to combine together individual sort of data elements. Here, they're individual strings, or individual character strings, into a single vector. So this just means combine these together into a single thing that I can pass as the value to this facets argument. 2-facet wrap. So, facet wrap, you can actually ask it, so it's automatically tried to figure out sort of a number of rows and columns that will suit this data decently. You can actually be explicit, and maybe I just wanted 2 columns, but 4 rows plus an extra one. Oh, remind me later. So if I wanted 2 columns, you can tell it by either telling it how many rows or how many columns you want, and it infers the next one. So if you say n col equals 2, it arranges them, 99, 4, 99, 6, 99, 8, etc. Same data, just different sort of orientation of how the plots were. So facet grid, on the other hand, is a little bit different. So it still takes facets argument.
You have facet grid.
Yes. Facet grid. So it still takes a facets argument, but this facets argument has to be of the form something tilde something else. In fact, the thing on the right needs to be something talking about rows, and the things on the left have to be something about talking about calls. So what goes on the left, we can choose one thing. So let's go year. And we don't need to put it in quotes. It's kind of annoying that there's this, you have to kind of remember when you can put things in quotes, or when you have to put things in quotes and when you're allowed to not. The rule here is if there's a tilde, you don't have to put things in quotes. So year tilde, and what did we have? Sil as the other one. So this one, notice how we've got, we're just like we have all combinations of cylinders in year, but we're just wrapping them around. This one will force a grid structure such that every year is represented as a row and every cylinder type is represented as a column. Now, this actually highlights that missing data a little bit better. So first of all, it's made it so that each panel is just only the tops of the columns and the sides of the rows are being labeled. Whereas before, when we had it as facet wrap, every facet had its own label. And we actually get a panel that's the 99 5-cylinder that was missing data. Whereas here, it just, facet wrap just omits any panels that don't have data.
Can you scroll up to the one for switching the direction that they were?
Okay, so there's the making it 2 columns. We said n col equals 2. Here's the one where we just let it decide rows and columns all by itself.
But there was a code.
Oh, code to do it? Oh, do you mean like where was this one?
Just to let you know, it wasn't actually a typo. The Jetta in 2008 was 5-cylinder.
Ah, okay.
Yeah, I forced it to return the rows, and I'm like, okay, I'll check it.
That's difficult.
It was accurate. Hasn't caught on. Sorry? It hasn't caught on.
Yes,
Mhm.
one
It didn't
time.
sell very well. Wasn't worth very much on eBay. That's the first result.
So, yeah.
If this,
Oh, so go ahead.
if this is like what like facet grid looks like, why would you like? To me, this looks a lot nicer than facet
Yeah.
wrap.
Yep. If you have a lot of variables that you want to combine together, facet wrap is really the only way, because this just tells you row and column, so you can
Right.
max get 2.
Right.
But if you want to wrap a bunch, I think that if you are trying to look at a whole bunch, you're not going to. I'm skeptical that you can do it with facet wrap, but I'm skeptical that you'll get anything out of seeing that. So, but that's a human psychology problem. Now, what happens if I wanted to use facet grid, but have just the year as rows? Now, I could use facet wrap and tell it n rows equals 2, and it would automatically figure out that I just wanted rows. But I actually find it useful to just use facet grid, in which case, if you want to make it so that there is something on one side of the tilde but not on the other, you can't just delete the thing that's on the other. You have to replace it with something. So, and the thing you replace it with is a period. So what this means is I want to put year as the thing splitting up the rows of facets, and the thing splitting up the columns is nothing. So just a single column. Run that, and it runs just fine. Ditto, if I wanted to split up the columns by year, but nothing by rows, so just a single row, I put a period in front of the tilde, left-hand side of the tilde. That would show it like that. So far we've been dealing a lot with geom point. We could, let's talk about some other geoms. There's lots of geoms available. The R for Data Science has a nice little table of all the geoms available. I'm going to copy this a little bit and put it down here. so let's create a plot where it was that silly. I'm going to take off the color differentiation, put engine displacement on the x-axis. I'm going to put all the data at y equals 0. And I guess we can keep the labs layer. We're not going to have a y-axis yet. And color is no longer there. Remind me later. And get rid of my facet. So get rid of the facet layer in the combination. All right. So I've got my blank canvas. I'm adding a points layer where the x location of the points is mapped to the displacement column in NPG. The y location is set to 0. The alpha is set to 0.5, so semi-transparent points, and they're going to be jittered a little bit. And we've got labels for the x-axis and combine it together. Okay, I actually wondered if that might happen. It doesn't like jitter in combination with a fixed y. Maybe if I did geom jitter and said width or something. So here's that same plot. Or sorry, here's the plot of just the engine displacement data with the opacity of the points, the darkness of the points indicating sort of overplotting. What if we were to put each of these points into, what if we were to separate this axis into equally spaced bins and count the number of points inside each of these bins? What would that be? Okay, so histogram. So there is a histogram function that does that all automatically. So we'll keep this points layer. I'm going to add something called hist layer. Instead of geom point, geom histogram. Take off this setting y to equal 0, because histogram is automatically going to take the raw data that we see, and it's going to compute a statistical property of that data. That is the count in each bin that it creates. And I guess let's leave that alpha. That'll make the bins semi-transparent. So in addition to putting the points layer, we'll add hist layer.
Why do you still need the points layer?
I thought it'd be fun to put it at the bottom.
Oh, so it'll display both of them.
Yeah.
Okay.
Something a little not conventional, but it provides information, and it doesn't cost to put it on there.
Sorry, can you go back to your Instagram code?
Oh, yeah.
No,
Okay,
no,
so
not right there.
hist layer, gm underscore histogram, data equals MPG.
Oh, I just got the whole thing to work with jitter.
So it's the exact same as the points layer, except that we're... Oh, yeah, sorry.
Just the bins that go under the hist layer.
Ah, we're about to get to that.
Okay.
So you would only ever have an X for histogram of this?
Yep. It's like the only property that's
Yeah.
dependent on the data is the x-axis. It then does a statistical transformation, counting, to binning and counting to get what should be on the y-axis then.
That's the geom jitter. Geom jitter requires
In addition to plotting the data, it has given us a little warning. Stat bin using bins equals 30. Pick better value with bin width. So what's going on here is that every geom has a default statistical transformation that's done. Points, the default stat, so if we actually go geom point, the default stat is identity. Identity means like nothing. Just don't do any transformations. Do what is right there in the data. Default histogram. Geom histogram has a default bin or stat of binning. Oh, sorry, that's for freak poly, but the same thing for freak histogram. Default stat is bin. So whenever you have a stat, it's doing some sort of statistical transformation that possibly has options for changing how that transformation is done. So what stat bin does, in fact, this also is the help page for stat bin. There's two arguments, bin width and bins. So it's saying here bins equals 30. So what it's doing is across the range that the data takes, it's creating 30 bins. If you were to go through and count these, there'd be 30 bins here. It's suggesting we either use the bins argument or the bin width argument to change that to something that we might want better. To do that, we can just include that argument in the call to geom histogram itself. Geom histogram is going to see this argument named bin, know that that's the name of an argument that the thing that it calls behind the scenes, stat bin, to do that statistical transformation. It knows that stat bin will accept bin, or has as one of its arguments, bin, or I guess bins. So if we put bins equals, say, 10, it's going to pass that along to stats bins. Stats bins is going to use 10 bins instead of 30 bins. So if we run this a little bit again.
Sorry, why are we picking 10? Is this just arbitrary?
Completely arbitrary.
Okay. Is it possible to, instead of changing the number, to change the width?
Yes. So one implies the other. So you can either set the number of bins or set the width of bins. So here, setting the number of bins, I'll comment that out. Instead, I say bin width equals. So putting the number of bins is kind of useful because you don't need to know anything about the scale that you're talking about. If you're setting bin width, you do have to sort of take a look at the scale, see what sort of reasonable size. So I don't know, 0.5. Let's try bin width of 0.5. That's going to create, I don't know how many bins. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
So could we just go up?
Yeah. Yep.
Oh, mine did not.
So.
Higher. So you get an error above
Aha.
the point.
Okay, so the points layer is just the same as before.
Okay, you still have to have the y.
Yeah, I put the y as sort of being fixed at 0.
So it's only in histogram if you don't need to put a y.
Yeah.
Mine does not look like
Are you putting dispel as the
Yeah.
x thing?
Yeah.
Bin width equals 0.5.
Yep. Oh, wait, nope. I had 5. Not 4.
Ha ha ha.
That would do it. Much better.
So, one good idea, histograms are actually relatively looked down upon in the world of data visualization because the choice of bin width actually is rather influential on sort of the shape that you see. Certainly it's the case that if you're looking at histograms, you should look at different bin widths. One trick that I actually learned or realized this morning, thought of this morning, is we've already seen that we can actually put a histogram and points on top of the histogram. Can we put a histogram on a histogram? And indeed, that is the case. So I'm going to copy that whole hist layer section called hist layer 2. Have everything the same except instead of bin width equals 1.5 or 0.5, I'll say it's 1.5, so slightly bigger bins. Run that to create that object. Having created that object, I need to add it to the list of things that we're adding together. And rerun the code creating my plot. And now we have the two things. Now notice the height of the I guess larger bins is higher. That's because larger bins can catch more things. So you can go crazy and add a third one. That's maybe a bin width of 0.25. Call it layer 3.
Would you think it useful to set bin width as some percentage of the range of your data?
That's effectively what setting the number of bins would be.
Well, I recognize it.
Yeah.
Oh, yes. Okay, I see. But you wouldn't necessarily take that approach in that you create 3 layers based on like different percentages to get a more accurate reflection.
Or just easier choice in the range.
Yes, you're not
maybe
arbitrarily guessing at values. I don't know.
Yeah, I mean, I'm actually more used to certainly setting the number of bins rather than bin width directly.
Okay.
But yeah, I just came up with this visual earlier today and thought it was kind of cool. So you have the raw data, alpha indicating the amount of overlap, and then you have sort of small bins, larger bins, even larger bins.
It kind of looks like a city.
Yeah,
like
yeah.
a city skyline.
Yeah.
Tell me more about that.
But yeah, I mean, this might be kind of useful. There's certainly better tools for visualizing a distribution of points. The key thing here, one of the key things here I wanted to show was that you can layer arbitrary numbers of geometric layers on top of one another into the same plot. Now, one thing is that this has been really redundant code. Like, look at all this. We can shorten things up. So up here, when we had the call to geom_point, it was just empty. It turns out that you can save if you know that the same data is going to be used in every single one of your plots, you can just put it in the original call to ggplot, the creation of the blank canvas. Having done that, we can actually delete that call or that argument in every single one of our lower ones, reducing the amount of code that we would have had to type if we thought of it in the first place. So the way it is this way, we've got a blank canvas, but with a default sort of pointer to the data MPG. And then all the points layer, all the different layers here, just say the mapping and whatever's constant about those layers. So when it adds things together, it's going to get to the hist layer. The hist layer is going to say, look in the dispo column. That layer doesn't have the data that it's supposed to be pointing at, but the canvas, the overall canvas does. So that'll resolve itself to point to the dispo column within the canvas layer. Similarly, we still have a lot of redundancy in this. The mapping is the same across all of our layers. Do you want me to close the door just for while they're between classes? So, ditto, we can take this mapping and cut it out and put it in this original call to creating that blank ggplot canvas. Remember to put the comma back at the beginning. So we've got data equals MPG, new line, comma, mapping equals this. Now our points layer, we do want to tell it y equals 0. And y now is the first argument, so it doesn't have a comma at the beginning. Hist layer, we can get rid of its mapping argument. Alpha is now the first argument, so we can take off the comma. Ditto hist layer 2, take that off, take off the comma. Ditto hist layer 3. Whoop, oh, there we go. So the code is a little bit like, well, it would have been easier to type had we started out that way. I'm actually not sure. So we've got alpha equals 0.5 in all of these. Oh, well, let me run this right away. Without tweaking anything. And it prints. So I didn't lie to you. You can simplify it that way. One thing I'm curious about is whether I can put alpha. No? It doesn't work?
It did not work.
Okay, all right. So no, you can't specify a generic sort of property that's the same across all your layers that refers to an aesthetic attribute of the geometric objects. So no, okay, good to know. But that makes it a little bit easier to see, or easier to type. So this actually is the more common way of doing things, putting the data that's common across all your layers and the mappings that are common across all your layers in the initial call to ggplot. Indeed, the mappings actually don't need to be common across all your layers. They just need to not conflict. So you could have one mapping here and another mapping in here. Those plots might not make as much, well.
What do you mean?
Yeah. So if I needed another mapping, so if I didn't want...
You mean like different X and Y's across plots?
Yeah. Well, they always have to have the same X, so I can't give anything with a different X, but geonPoint can take Y as something that's varying. So I can say mapping equals AES, and instead of... I'm going to map the color and map it to CYL maybe. So notice the mapping that I am supplying to this one doesn't conflict to the common mapping, the mapping that's common across them. So if you happen to have some other aesthetic attributes that's unique to this geometric object that you want to make different across the different, that you want to make data dependent, then you can add mapping for that specific property in that specific geom and still share the thing that is common up here.
Out of curiosity, this is a random question. Can you make 3D graphs in art?
3D graphs that you can dynamically rotate. There is something called RGL that will do that.
I have, like, no
But it's
need
not
to make
GG.
one, I'm just
Yeah,
curious.
it's not ggplot based. There's a new one that sort of, there are versions, sort of pre-release versions out called ggviz that does allow you to do 3 interactive plots, but it's still in the works. Now another, so I just sort of showed you how you can simplify your code, and it's kind of rare that you ever have different layers that have different data. So this certainly is most common. I teach everybody the original way. I find people learn better that way. And there are cases where you do want different data coming from different places to be all in one plot. I've certainly encountered those, and I think it's useful for people to remember that you can have each layer having its own data coming from some other thing. But this is much more common, so you're going to see this a lot. You'll have ggplot and data and mappings all specified in there, and then you start defining any sort of geometric objects that you want to use. Question?
Actually, I'm assuming that this is possible, but within something like geonPoints, if you wanted to plot individual series, could you do that within the same geonPoints object, or would you have to do separately objects for each series?
So how do you mean each series?
So it's like, let's say you're looking at 2 outcome variables.
Mm-hmm.
Would you be able to specify if you were to run points using displacement
to make it sort of clinical? So what are the 2 IQ subscores? Like WASI, verbal, and math.
Like verbal and nonverbal?
Verbal, nonverbal. Okay, so they are on the same scale. So in theory, you could have them. They're not going to be like way different scales. But you're saying plot them
Yeah,
at the
I
same
mean,
time?
I guess it more has to do with the organization of the data frame, because especially if you have something on the same scale, then you just have another column and you call in by like IQ score test. But if they were on different scales and you couldn't record them in the data frame in the same columns, and you had to have two different columns, and you wanted to call in different Y values for each,
so one thing I didn't show you in the faceting is that you are able to specify whether there's a common scale to both facets, or whether the facets can narrow down to just fit the data that's in that facet or not. That might deal with the scenario you're talking about. You create a faceting, or just two different plots. Because if the data truly come from completely different scales, so you're talking about IQ versus
ability to run.
Time in a 100-meter sprint.
Yeah.
They're going to be a very different scale. Well, for some people, mostly. different scale. I thought I saw a question coming up over here.
Could you just scroll down a bit more? Thank you.
So this is just copying those. It's the same thing as we had before, but the data and mapping are all removed. So one other thing that I guess the way in which I've shown you differs from the way that you'll see code online and elsewhere is that people don't typically store like the base thing in an object, and then this layer in an object, and then this layer in an object, and then add them all together at the end like we have. Usually what they do is they say, I'm just going to create that my plot right away. And so I would be immediately adding geom point, immediately adding geom histogram, immediately adding this other one. So the difference here is that you're not like storing each layer away into its own object and combining them at the end like this. You're just creating them and combining them as they are created. And indeed, people often don't like bother creating an object for the plot itself. They just run this. And the default, again, for most things in R is when you run a function without returning its value to an object, it tries to print that object, the return value. So
I got an error saying geom point requires the following missing aesthetics. Why?
Aha, yes, good call. Good catch. When I was cutting out stuff, I thought I remembered that there was another argument here that I was forgetting to put back in, and it's y equals 0. Good catch. Yeah, because in the common mapping, we gave it an x-axis value, but we previously had y is equal to 0 there. I've taken it out. Geom point requires a y. So this is the format that you'll see most code. Maybe not with the like extra lines and tab indentation that I do, but usually people will create a plot by layering up all in one single call to the functions and adding together all in one go. I like to show you guys with each layer getting its own object and then adding them at the end, just to be explicit about how things are happening.
Could you put the y equals 0 like in the mapping part instead of putting it under geom point? Would that work?
Let's try. Nope.
No. Okay.
The question is why no? That got broken because geom histogram doesn't like there being a y there.
Okay.
But is geom point okay with a y being there? Notice a benefit of doing it with just without assigning into objects, just adding them all together, is that you can actually select a subset of them to just run that little bit. So yes, you could have put it as y equals 0 right there, and that would have been okay for geom point, but geom histogram doesn't like there being a y in there in the common mappings, so that's a good reason for putting y equals 0 there.
And sorry, we were pulling y equals 0 out of the AES function simply such that everything was going to be 0.
Yeah,
and
so
it
that,
didn't alter with the data.
yeah.
Yet when we put y is 0 into AES, it didn't affect.
It's still, yeah, you're right.
Because that's one of the differences between like the point and jitter commands is that the jitter wants a y value inside all the time.
Gotcha. So here, does that actually mean if we put that and it will be okay with us doing this? Yay! Yes, not a super meaningful plot, but
If I get an error that says invalid argument to urinary operator, and I get it a lot of times.
yeah, that is an annoying function. That is occurring because you're putting the plus. Sorry, that's an annoying error message because it's not super informative.
Yeah,
I believe that you're doing a plus or some math at the beginning of a line when it's supposed to be at the end of a line if you're separating.
I'm putting my pluses here, so maybe I put them up here like
Yeah,
this.
exactly. Now you can put that the name. So what she encountered was she was running this. I'm going to take this part off. So put the y equals 0 back on. All right. She was running it like this, which seems like it should work, but what happens is that it runs this, and then thinks that it thinks that it's done all its computations, so it just creates the empty ggplot object. It doesn't see that this is a continuation, so to tell it that it's a continued computation, you have to put the plus on that line. You can put the geom point on the next line, which makes it look a little nicer, I'd say.
Also, mine doesn't light up, like the functions aren't yellow, things like that.
I think that's just a function of what settings you put. So if you go into your options, command, comma, opens up those main options. Also, if you go up in the top tools, global options.
So where did you get options?
Tools up top, global options, and appearance. You can change what appearance. I like the vibrant ink appearance.
I don't have that one. That's unfortunate.
So when you simplified it like this and you took out the object names or whatever, so you know how you had like
Yes, so I
histogram
wasn't
1,
assigning them
2.
into objects.
Yeah.
Yep.
So when you're doing that and you're including multiple histograms you want layered on each other, you don't have to like label.
No.
Okay.
No.
So then when you do the like my plot equals.
Aha! We don't
do
even
you
have
take
that.
out?
Yeah, we don't even have that
You
anymore.
just do print my plot.
Well, what I did is, so yes, if we had my plot equals that, then we'd have to have print my plot here.
So, but without that, you can just run it.
But yeah, without an assignment into anything,
Oh,
it just automatically prints.
okay.
I like the merge.
Okay, cool.
Italic. What is the tail? Makes the notes italic. Merge it forward.
Guys are playing with a different.
Sorry.
Yeah. What else did I want to look?
Oh,
So,
it has stuff on, like,
I mean, that largely repeats everything we talked about the other day. I don't think. I mean, there's lots of cool other stats that you can do. or sorry, not stats, but geometric objects. So, but I'll leave it to you guys to explore those. And I guess we'll use Geom Violin, I think, maybe when we get into the actual stats part of this. Again, this is sort of getting you guys used to, first of all, R, and we'll do a little bit of plotting. So I wanted to expose you to ggplot, because the plotting that we'll be doing will be using ggplot sort of behind the scenes, and we might want to, well, yeah, there's a couple plots that we'll do that we'll be doing ggplot by hand. But it's also just a generally good skill to have. And there's lots of cool stuff that you can create with ggplot generally. That, yeah, ggplot makes it easy to create cool graphs and things far easier than the base plotting packages would permit you. 144. Just deciding whether to start a new topic. Let's see, where is my note? So there's data transformation. Let's do a little bit of that. So we still haven't gotten to the point where we're reading in data, and that's going to be a little bit separate. But we can start talking about once you've read in data, which we'll talk about next week. Once we've read in data, how do you sort of manipulate things? So one thing that came up when we were looking at the MPG dataset is there's that 2008 5-cylinder car.
There are two of them.
Yes. What if we wanted to like pick that up? Or what if we wanted to take a look at that, like the entries in the database that were associated with that? We're going to use the dplyr function, or the dplyr package, which I believe should have been installed automatically by Tibble. Oh no. Okay, so I have to install it. The plyr part comes from so originally there was just a package called plyr that allowed you to very easily manipulate data. Hence, plyr being a tool, it's sort of a general purpose tool. dplyr is very specific for data frames, Tibble being included as that in that category. So the way, I installed dplyr. Question?
Oh, okay, and then you took the library.
Yeah, now I do
Okay.
library. Well, I guess I did it up above, but I didn't actually run it yet.
But-
there we go.
Okay, but we have to. My internet, I think it's working.
Mine says it's downloading.
Mine says object it's DPLYR.
5 megs. Mm-hmm.
No, it just kept saying error in install packages object D.
How do we just keep going?
Question?
How do you, if it's not listed in the, like when you click on packages, if
packages?
it's not listed there, how do you find it again?
You click install. So it means that you haven't installed it yet.
Oh, and then, okay, gotcha.
Mm-hmm. Or you can just type install.packages.
So I loaded it, and when it says something about the following objects are masked.
Yeah.
Blah 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 blah.
Yeah.
So that just means it has some function.
So what that means is that there are actually, so dplyr provides a function called filter, but the package stats, which is automatically loaded when you start R, also provides something called filter. So this is giving you a heads up that if you were to type the word filter before calling dplyr, you're going to get stats filter. After loading up dplyr, you're getting dplyr's filter. So it's kind of saying we're overwriting things. you can always get the you can always assert which version of filter you want by being explicit. To do that, you can say dplyr : filter, for example. I've actually started in R4DS. He started to do that. That's much more common in other programming languages, to be explicit about where certain functions are coming from, what packages they're supposed to be coming from. I've started to see it more in R. It does mean more typing, but often the trade-off between typing and being explicit falls on the side of being explicit.
Sorry, can you explain?
So what this,
or if it's not something we need to know.
No, it's useful. So
Okay.
if I were to unload, let's see, unload dplyr by unchecking that, there's a function called filter available.
And but the filter function with dplyr is different than the
Yes.
Okay.
Yeah. So there's a function called filter available. I can start typing it. It's gonna give me what the different things are. If I were now to reload dplyr and start typing filter, interesting. It's the default that it's going to start using is whatever's being loaded more recently. So that's dplyr. So it's the dplyr filter that it will start using. If you ever wanted to be explicit and use...
What's the difference between...
Well, I guess in theory, the only way now, after loading library dplyr, the only way now to use the original filter is to ask for it by saying stats : filter.
But what's the difference between the two filter functions?
So this filters a linear time series. It does a this is like a somewhat is it even so this does like a almost like a running some sort of running smoothing filter through the data, which is completely different from what dplyr does. It's used for a different purpose. dplyr is something where it allows you to select aspects of the data or to cut out aspects of the data. So we'll talk about it more. Those are just two things that get masked. So filter is one, lag is one, intersect, set diff, set equal. These are all the names of arguments of functions that get sort of overwritten.
And so if we wanted to use the originals for any of those,
yeah, you'd have to stats filter, stats : lag, base : intersect, etc.
I don't know if mine is right. The internet's pretty.
Well, I mean, we're just gonna go through the R4 data science now, so all the code is right there, and you should be able to just the requirement for, or I guess it's not really necessary for you to be typing in the code at this stage, I guess.
Just out of curiosity, what is the advantage of the dplyr function or the dplyr package over the base functions that are provided?
It introduces a style of R programming that has, I guess, really taken off in the last couple years, that people are finding is easier to both use and teach to new people. I'm certainly used to the old style, and this is my first time teaching the new style, but my understanding is that it's better, so I thought I'd try it.
Because I'm just used to setting.
I'm just trying to find this on the.
It's under data transformation.
Oh, okay.
If it doesn't look like it, just send me this contract.
Download it in NIC flights.
Right, NYC flights, is that already included too?
It isn't, but it doesn't seem to be in the package database either. I got had non-zero access status when I tried to install the package.
I think that's the sketchy internet. Well, let me see. Maybe I'll get a non-zero.
What was the name of the package?
Nope.
No?
NYC flights 13. Oh. So if you load in the flights package, NYC flights 13 package,
Sorry, is there a way to, like, you can command return to run it, but is there a way to select a line of code to run without clicking? Like, if you wanted to do everything by typing and not have to click to highlight.
Shift, and then holding shift and then using the arrow keys to like go down to select lines.
you don't even need to select the line. If you command return while your cursor is on a line, it's just going to send that line.
Okay, send that line or everything below it?
It will send, so if that line is just a computation all unto itself, it will send that line. If it will send until the computation is complete all the way down to, so if you're on the first line of an ongoing something that takes several lines to compute, it will send the whole thing. Also, if you're in the middle line of something that's to compute, it will send the whole thing. So it's actually really, I just discovered the latter feature this morning. So with the NYC flights, this is a huge data set, 330,000 flights. You obviously wouldn't want to show the whole thing, so it's actually a tibble. And you could view the whole thing, but probably don't want to. So the basics of manipulating data with dplyr is that there's a filter command which selects observations depending on what their values. You can rearrange the rows of the data. I actually almost never do this because that's useful for when you're like looking at the data and trying to like see, okay, what are the most extreme values and the least extreme values. I guess I use that sometimes. To select variables by their name. So if you're just selecting out certain columns from the data, if you're trying to sort of subset the data down by the different columns, if you're trying to create new data, new columns, and if you're trying to summarize data, so you're collapsing the elements sort of categorized by some set of columns and collapsing down the other columns to some summary statistic like the mean or something.
Can I ask a more basic question, please? For the previous data set, you were able to type and see just the first couple lines of it. What did you do to do that?
Flights is the line that we have. So,
oh, it's called flights. It's not NYC flights 13?
Yeah.
Okay, so the data set is called flights.
Yeah, so...
data set is called... Cool.
So all of these kind of, particularly summarize, imply that you're going to be sort of grouping the data by something. So you maybe, if you had two groups in your, or if we were to take the example of the MPG data sets, we might group by automaker and get the mean highway mileage per each automaker, that sort of thing. So, and they're all structured to work similarly. They all have a first argument which it expects the data frame. The subsequent arguments say what to do with the data frame. I showed you a little bit before, I thought, using the $sign to look at columns within a data frame. Here, because dplyr is smart, you won't have to. It will automatically see that you want to refer to If it has the data frame argument, you don't need to keep telling it what data frame things come from. And it always spits out a new data frame. So the example he has here is like a first use filter. So if you just call the function, not assigning it the result of this function into anything, so it's by default going to print its result. If you just call this result, call this function filter, first argument is data. He hasn't named it, but let's actually take a look. If I do question mark filter to look at the help for filter, it will actually see that there's two things called filter. So if we said, so we don't want the dplyr filter. So dplyr filter, the first argument is actually called dot data. And then the other arguments are dot dot dot. So dot data, a tibble. So it expects you to put in a tibble. And the other ones are logical predicates. Multiple conditions are combined with and. That's not super helpful help. So happily, the walkthrough here is helpful. So what this is doing, logical predicates, logical statements. So remember, double equals is a logical statement. What it's saying is that you can put any number of comma-separated logical statements after the first thing. So the first thing, he's omitted the argument name, which is dot data, but he's just given its value as flights. And everything after that are each treated as logical statements that are, once you've supplied them, they're combined together with an and. So what this is saying is, in the flights data, look in the month column and grab all those months that are 1, but also look in the day column and grab all those days that are 1. So the combination of these two arguments or logical predicates is that it's only going to yield the January 1st days. Month equals 1 and day equals 1. I'm going to copy this and put it in a little code window because I want to show you something.
So when I tried doing that, it told me that it couldn't find function filter.
Ah, so did you do library, dplyr?
Did you spell filter?
I spelled filter wrong.
Oh my god, yes. Flitter.
Yeah.
Wow.
Okay, so I'm going to convert this to the kind of code that I like, which is the different arguments on each line. I actually give it, the first one is a named argument, so I can give it the dot data. But the other ones, they don't have names. Like in the usage, it's just dot dot dot. So there's no names to give them.
Wait, so, sorry, because it says multiple conditions are combined with and. So
Yeah.
is it just reading whatever you put in and combining it with and itself? You don't have to put that.
Exactly. So I could have, so this is just literally the same thing that was in the document, but I added white space.
Right.
I could have done this.
Right.
This kind of, if I were to do that, I'd maybe want to put parentheses around things to be a little bit clearer what the, I have trouble remembering the order of operations when without parentheses. So this is clear that this thing and this thing. But that's what this does anyway. Putting a comma sort of means that you don't have to put the parentheses. It's kind of.
Is it called flight or flights?
Flights with an S.
Because it told me it couldn't find that.
Did you load the NYC
Yes.
Flights 13?
Yes.
So you installed it. Did you also run that to load it? So if you type flights, you don't get that?
Wow, so that still
But
gives
you also have to
big
misspell flights.
No, check that. Hold on. So the 2 equals, that means like exactly equal to, right? So this
Yes.
is saying like filter it so that month is equal to 1.
Yep.
Exactly what I
Mhm.
Okay. It still gives like a really big thing.
Yeah, because that's a lot of flights go out on all January 1st. So 842 flights from just the years that it has tallied. Come over and see.
Hold on, I might have figured it out. Oh, there we go. No, okay.
I just, you know,
Because my feet are under the seat.
No, not that tough. Typically.
Alrighty. Okay, so that's our first use of filtering. We've sort of subsetted the data.
And did you need to put dot data in, or could you just?
You didn't? No. No, I was just being thorough. Yep.
Oh no.
So we can, if we actually wanted to then do something with that data, I mean, it just prints the screen that way. It's not super useful. If we wanted to do something with that, we, I guess I have it repeated down here. Don't need it. We call it Jan 1. Assign it into that, and now Jan 1 is something we can do some computations with. Alternatively, he shows an example here. Instead of month 1, day 1, he's got month 12, day 25, so December 25th. This is a cute trick. I almost never use it, but I guess it can be useful. So first of all, Hadley still uses arrows. I need to complain about that, but he puts parentheses around the whole thing. So we haven't really seen that yet. What that does is it tells R not only do this assignment, but also print the object that's created from that assignment. It's the same as saying Jan 1 print Jan. I actually prefer to explicitly put the print there, because if I don't want it to be printed, I can just comment that line out instead of having to like take off. The parentheses also kind of throw off the visual style of the way I do things. But you'll probably see that in this code, he might have the parentheses around things in order to, for the purposes of generating the then output below, it's there. So in this section on talking about filtering, we've already talked about all the comparisons that you can make. This time in the book hasn't, so he walks through all the different comparisons, shows that you can't use just a single equals. It's also, if you're looking for specific values, computers actually, funnily enough, aren't great at doing a computation and then comparing it to what you might expect as a human as the precise answer for that computation. It's because when you do the computation, it ends up having to sort of round at like the 64th decimal or something as it does the computation, that even if you do the computation and then undo the computation, the series of rounding that it does ends up yielding precisely, it doesn't precisely reverse itself.
You use like embed everything in a round function.
Exactly. And that's what near does. It's sort of like, to the extent, like it checks to like the 60th decimal place, or it checks to sort of a super long amount of decimals, but not so long that it starts getting into machine precision, which is what that term is for how many decimal places it should go. So that's what the near function will do. So if you ever find yourself sort of trying to filter by something that maybe came from another computer as a computation, you might, and you sort of have an expected value as a result, you might double check using the near instead of precisely equal to.
How does that differ from round?
Well, round, you have to tell it how many digits are. Near will automatically figure out like the number of digits it should go to, like given most computers. like rounds you're going to use if you want like to the fourth
Integer,
decimal place
yeah.
or even to integer. But near will still go up quite a bit to like account for the fact that maybe you do want to be able to detect when it's 2.00001 square rooted to the power of 2. That's not going to come. That shouldn't come out as equal to 2, because that is a scenario where the input on the left-hand side here was pretty clearly distinguishable from precisely equal to 2. So near is available. We're not going to need to use it, I don't think. Like, just FYI for your own data sometimes. Here's a little graphic of all the different like consequences of the like different combinations of the logical operators. So the bar, that's actually one that I haven't talked about. And is one, I don't think we talked about combining logicals with and, but and is just the logical and. So if you have true and true, that comes out as true. True and false, that comes out as false. False and true, that comes out as false. False and false comes out as true. So it's and really is the same as like equals equals. Or is done by just that straight line shift. And on Mac, the number right below the delete key. Not sure what it is on the PCs. Something over there in that general area. Or is, if anything, if there's a true on either side, it selects it. So if you want both of those months, then it would be month equals 11 or month equals 12. It's above the...
I tried that
Above the
not
enter key.
straight. Oh, that's because I'm writing in italics. Never mind.
Uh-huh.
It's just like, it's not straight up and down.
So,
Okay, never mind.
critically, if you're going to use the or, like if you're going to be doing it that way, you have to put the month equals equals on both sides of the or, because or is expecting to do like a, it's just order of operations stuff. I wonder. No, yeah, it's just order of operations. You need to be verbose like that. So he has a couple examples of like sort of complicated expressions using logics. So this is saying, look, get all the arrival delays that are greater than 120 or departure delays that are greater than 120. And I want not those ones. So I want everything that isn't arrival delay greater than 20 and departure delay greater than 20. And in this example, he's just showing that sometimes if you've got a complicated expression, you can actually simplify that expression by changing the comparisons. So instead of greater than 20, how about we just grab all the flights that arrival delay is less than or equal to 120 and departure delay is less than or equal to 120. These are going to AND together. So you're going to get the same result as these two, but this is easier to think about and write. So Q any. Okay. Yeah, that's not one that I've... So that he has a little thing here, it goes off on a tangent to talk about cum any, but I've almost never used those. One thing we haven't talked about so far is when you have missing values in your data. Often when you're doing any kind of experiments, there might be a scenario where the person, I don't know, gave up during the experiment or just refused to do one task if you're doing clinical examination. And so you just put like an A in there. I think we talked about when you're reading data in, there actually is an argument in the common data reading functions to specify what that is. Sometimes people put 999 when something's missing, or null or something like that. So you can tell R when you're reading in data what to treat as NA. And we'll talk about reading data again next week. But for just to clarify, whenever there is NA, that actually does have consequences. We had the example of the taking a mean, and when there were NAs, we did that on the very first day, I think. So when you have a vector, you're taking a mean of the vector. One of the arguments to the function called mean is na.rn. If there is any missing data in your vector that you're taking a mean of, and you leave it as the default, leave the na.rm equals false, the result is going to be NA, because you can't compute a mean including NA data. Ditto when you have the scenario where you're trying to do a logical comparison and there's NA data in the comparisons, you're going to get NAs out. So if you try to say NA is greater than 5, well, it doesn't know. And you can sort of interpret, whenever you say NA, say, I don't know. Some value is greater than 5. Well, I don't know. Some value is equal to 10. I don't know. So all these things, and when you try to actually do math on them, they're going to come out as NA. This one occurs sometimes. I guess the general rule is if any side has NA, it's going to come out as NA regardless. So if you want to actually ask if they're both NA, you'd actually, let's see. There it is. You can use the isNA function, and that will yield a true or false value. So you could say, for example, let me go here. So there's NA equals NA. Intuition suggests that that should come out as true, but it's not. It's NA because R just gives up whenever it sees an NA and the logic statement. But if you say is.NA, NA.
What's the is.NA?
Is.NA, whenever it encounters an NA, it comes out as true. So actually, let's go back. A equals NA. B equals NA. So the question is, if we want to ask A equal B, comes out as NA.
Okay.
And that's because R has seen, oh, they're doing a logical test here. Look at one side. Oh, there's an NA there. Give up. I can't decide.
Okay.
So what you could do instead is say is.NAA, is.NAB. So is.NAA is is.NAA. If I run that,
No, but what is the is.NA?
it's a function that checks whether the value supplied as its only argument there is NA or not. If it is NA, it yields a true. If it's not NA, it yields a false. So let me create a third object called D equals 9.
Can you put your whole data set, like is.NA, and then your data set, and it'll tell you if there's any NA values in your data set?
You can go through each column and ask any, and then is.NA, and it will tell you if there's any NAs in that column.
Okay.
There's actually another, so the package that I wrote a long time ago that I've actually stopped using myself, but is still relatively popular, will give you, the little printout that you have for a tibble, sort of gives you some general information about what's in each of the columns.
Right.
Mine does that too, but it gives you a count for every column, how many NAs are in that column.
Right.
Might use that at some,
That's useful.
might show you at some point that when we start sort of dealing with real data. But to really nail down this example, so we take what R recognizes as sort of a I don't know anything string, NA. It's not really a string, the sort of symbol for question mark really. Puts it into A, puts an NA into B, and puts a real value into D. So if we ask A equals B, we don't know. If we ask, is the object called A, does it have as its value NA?
Okay.
And it says true. Is D also NA?
I don't think you've run D.
Oh, I haven't. False. So that's because there actually is a value of 9 inside D. So if we wanted to ask, is A have the same thing inside of it as B? We can't just compare them like this. We actually have to compare them using the is.na. And then, so that might come up in the scenario where, like, you want to know, do they have missing data for both their verbal IQ and their nonverbal IQ? If so, maybe remove them from the data altogether. If they have an NA just for one of them, keep them in. There's other ways that one would address that specific task, but I remembered we hadn't talked about that NA scenario, because NAs will screw up your logical tests. Ba-ba-ba. Now, I think I'm going to cut her off there. We'll talk about arrange and select and mutate and summarize next week, and reading and data next week. And hopefully that'll be the end of the giving you a little R warm-up before taking a brief interlude talking about stats philosophy, and then getting nitty-gritty into actually doing stats on data.